Good morning. How are we doing today? Can everybody hear me okay? I sound like I'm in a big cave. All right. Hi, my name is Jay, and with me today is Shankar. We're members of the Data Reviewer team. And we're going to spend this morning talking a little bit about Data Reviewer for Server. Folks, let's see a show of hands. How many folks have worked with Data Reviewer in the past? Okay, one. How many have just heard about Data Reviewer in this thing you saw today and decided 8:30 in the morning is a good time to go learn about it? All right, cool. That's a par for course. All right, great. So we will do a little bit of, we'll talk a little bit about the importance of data quality, and oftentimes it's sort of preaching to the choir, but we'll do it anyway. For those of you who are new to Reviewer, we'll talk a little bit about what it is and how folks have been using it. We'll talk about different methods for implementing a quality control process within your organization or team. We'll talk about how you can use some of the tools to analyze and report your data quality to kind of make more transparent how good or bad your data is. And finally, at the end, we'll have a series of references and resources for you to learn more. We'll probably go through and do about 3 different demos, and we'll take questions after each one. So we only have an hour, so we're going to try to kind of keep it moving. But if you have questions, go ahead and ask it. So for a lot of the folks I run into when they want to learn more about Data Reviewer, oftentimes it's because they've been called to the carpet and they've run into issues where they had some poor quality data that resulted in some sort of negative impact to the project, to the organization. So when we talk about data quality, oftentimes you need to think about it in the context of, well, how do different people in my organization perceive quality? So for stakeholders like executives or senior leadership, good quality data means reducing risk and liability to the organization. That risk could be financial risk. It could be impact to reputation. So if the organization's mission is to deliver services and products to customers, and they're not doing that, it could impact them negatively for their reputation, which then actually affects the bottom line as well. For managers, especially managers who are resource or stewards of data, good quality data means it's kind of a demonstration of effective data stewardship. For those who are champions for GIS technology within an organization, good quality data helps bring more people to the tent to invest in the system and leverage it in their business processes. It also allows staff to spend less time fixing errors usually found later in production and spend more time focusing on things of higher value to the organization, such as doing modeling and analysis. And finally, for knowledge workers, those are the folks who actually leverage this information in their work. They can achieve efficiencies by being able to have good quality data at their disposal so they don't have to do much rework, it doesn't route them to the wrong places, things like that. So once we think about the organizations and what constitutes good quality data, we need to think about what does that really mean. So good quality data really is very subjective, and it really is more of more based in how an organization uses information to make decisions. So if you think about like a national data set used to produce a cartographic product, the data quality requirements for that are way different than the same data set used to route vehicles within a small city. But regardless of the quality of data, think about there's different really aspects to data quality. So International Organization for Standardization, or ISO, has a standard for reporting data quality, and they break data quality up into different elements. So things like spatial accuracy. In some scenarios, having data that's spatially accurate is more important than its timeliness. So spatial accuracy just is how is my GIS data fitting the features in the real world? How complete is my information? This actually ties into some of the ISO metadata reporting standards, so you can actually document this so that people who consume these data services can be more aware of how good or bad the data is for the intended purpose. So the ArcGIS platform already has a lot of data quality control processes built into it. So if you're using geodatabases, things like schema constraints, range and list domains, geoprocessing tools that help you load and detect data on loading, help you improve quality. Using versioning is another opportunity to inject a quality control process into your production environment. There's also advanced data types, such as topologies and geometric networks, or in the future, facility networks, that will help you build business rules right into your geodatabase. So Data Reviewer takes those capabilities and leverages them, but it also provides additional capabilities for validating data in different ways. So there are tools that automate the validation using automated checks. There are semi-automated workflows and tools that help you do visual review or positional accuracy assessment of your data. What a lot of folks find powerful is the ability to take the results of their quality control process and actually manage them from cradle to grave to ensure that all errors have been found have been fixed. Because we're tracking them, we can also report them at any point in the process so we can engage stakeholders to let them know how good or bad the data is. So Data Reviewer, if you think about it in the ArcGIS platform, traditionally it's been used in desktop as an extension to ArcMap and ArcGIS Pro. So it's been a component in Pro since the 1.0 release. It's also been an extension for server since 10.1, where you can implement a lot of, and we'll talk a lot about that's actually the gist of today, is talking about the different processes you can use in the web. For developers, we have components in the JavaScript API, which we'll demonstrate today, so that you can build custom web applications using Data Reviewer for Server services. We also have a growing footprint in the .NET SDK for ArcGIS Pro. Finally, for folks who aren't developers, we do have a series of configurable widgets that can be deployed with the web app builder for ArcGIS, which is shipped with Portal online and available standalone. All right, so we're going to cover kind of the three major functional areas of Reviewer today. The first is automated review. How do we take business rules, implement them as configured checks, and how do we find our errors automatically? We'll also talk about semi-automated review, which is where I can't configure a check to find an error, but I need to have some tools to help me find it and manage it. And finally, we'll talk about quality reporting. How do I make people aware, provide some transparency to data quality in the organization? All right, so we're going to do that through this sort of overarching demo scenario. So this is a notional process improvement project within a local government organization. They're wanting to use GIS data to improve their emergency response. So they know quality is very important in making sure that this data is good because it's an important asset for routing vehicles to help people out, first responders. So here we have some success criteria. What do we want to do as a part of this project? So obviously we want to streamline data collection processes. We need to make sure our attributes that are important for routing vehicles are complete. Features are positionally accurate, as well as ensure that we haven't missed any features and that any errors found through this project actually get resolved and we know that we are moving forward. All right, so in our first section, let's talk about automated review. So this is one of the main drivers for buying Reviewer in a lot of cases, because we want to automate these processes. People, fixing errors, finding errors is really not that glamorous. So we want to automate this and make it automatic as much as possible. So automation is just essentially being able to configure a method for validating data. Because it's automated, it's very fast. And sometimes, in many cases, you can validate your entire geodatabase of features in one shot. It's repeatable in that you run the test today, you run it tomorrow, you're going to get the similar results. There's no subjectivity really in it. Now, a new notion we've been talking about in slight deviation from what we're doing in the future is that Reviewer works on a post-creation of a feature. So it has to exist in your geodatabase to be validated, which is fine if you have no understanding of how good the data is. You need to understand a baseline assessment of feature quality. There's also this notion that we're getting pushed on is to pre-validate features before they actually get created in the geodatabase at all. So you may have seen on Wednesday, we had a sort of a road ahead for our Pro SDK. And there were demonstrations showing pre-validating features before they're committed to the database. So just to be aware that there are these two different modes of validation. Today, with Reviewer for Server, we're looking at post-creation. In the future, we're looking more at pre-validation before features are created. All right. So out of the box, I think Reviewer at the 10.5 release has 43 different automated methods for validating data. And when we think about grouping them, there are a series of checks for looking at attribution of your features, right? There are a series of checks looking at feature integrity, looking for invalid features, invalid geometries and features, looking for features that are dangling. There's also checks that validate spatial relationships between features in different feature classes, features in different databases, features from different sources altogether. And finally, there's a check for looking at your metadata and validating its content either against an established metadata standard or against custom rules you may have created for the actual content itself. So when using ArcMap for server, an organization will oftentimes have lots and lots of different business rules they need to implement. And the process is going through and identifying those business rules, configuring them as a number of configured checks, and persisting them in what's referred to as a reviewer batch job. A batch job is a container for all these configured checks. And it really, in a way, it does capture domain knowledge, because the idea is you get all the subject matter experts involved to define what is good quality information for the organization, and this is just a physical implementation of it. This is oftentimes shared across the organization, either through just sharing it to one another or using things like Workflow Manager, where you implement that as a part of an overarching system. Esri also produces a series of quality control templates based on these reviewer batch jobs. So if you go out to the solutions.arcgis.com site, you'll see examples of quality control templates that are based on Esri's industry published data models. And they're really kind of a starting point to get started with it. They've been built with using Esri professional services staff in working with customers to define some baseline validation methods for your data, or for data in these vertical markets. So it's a good, something you could download and use and sort of see and then adapt as to reflect unique adaptations you might have done to the data model or business requirements you have for your organization. All right, so in our first demo, we talked about this need to, as an organization, identify business requirements. And this is the sort of the sausage making part of Reviewer, which is getting people together to agree about what good quality data is. And that's not an easy task, so I don't want to trivialize that. So that is usually the long pole in the tent when people say, hey, I want to implement Data Reviewer. Well, first, what does the organization consider good quality data? So getting people together, that could be different stakeholders that use that information in different ways. Capturing that information into what a functional requirements document might be. What are the data sets I'm using? What are the quality requirements based on commonly agreed use patterns? The implementation of that functional requirements falls down into either automating processes using reviewer checks or setting up workflows for doing semi-automated review, which we'll talk about next. And then what are the reporting requirements? So in the demo today, we've got a series of business rules that we've implemented as a reviewer check. That series of checks are going to be used from server to validate data that's been created to support this project by a series of data contributors. So in our example here, we have some outsourced contractors or contributors who are providing data or contracted to bring in data, and they're uploading that data to a portal. In that portal, we're going to use Data Reviewer's capabilities to automatically validate those features and provide them back out as feedback to the contributors, letting them know how good or bad that data delivery is. Okay? So let me turn it over to Shankar.
Thanks, Jay. Is it audible? It's good? Okay. So what I have here is a contributor portal. So as Jay mentioned, a contributor logs into this portal, tries to upload his data, has a zip file database, and provides it back to the organization. The organization on its part has already pre-configured rules or batch jobs behind the scene, and they have set it up so that when a contributor uploads his data, they can actually log in, they can actually provide that and take that information and validate them against automated validation services. So let me log in as, let's say, Team A here. So here I have a map of address data. So I'm collecting address points here. So as I collect address points, as a contributor, I come in and upload the data. So here I have a widget which provides me a mechanism to upload the data. So I put in information saying new tracked updates, some description on that, define a date, which is today, and I'm going to go ahead and provide my data here. So I have an uploaded a zipped file database which contains some address points here. So I take that and provide it to the organization. So the application uploads that to a server and allows the contributor to trigger the validation here. So he goes ahead and says submit data, and as he submits the data, what happens is it uses the data reviewer server's automated validation capabilities to trigger a validation on these jobs and then reports back issues back to the contributor. As you can see, actually it ran a job behind the scene. It actually returned some issues reported back to the contributor. So to understand this architecture better, let me just now switch to the architecture of what we just did as part of this first demonstration. So what we have is clients use the web APIs, ArcGIS Data Reviewer's web APIs, which will allow you to actually interact with the ArcGIS Data Reviewer's REST API to trigger a validation while submitting data. When they trigger a validation, it uses reviewer's map service, which offloads the work as a schedule to the validation service, which is a geoprocessing service. So once a validation happens, the validation actually uses the data that has been uploaded by the contributor and then returns results to the reviewer workspace. It writes it to the reviewer workspace, and since the reviewer workspace is available as part of the reviewer map service, they can look at the results once the results are available. So as part of the validation service, it returns back an execution details, and based on the execution details, we go ahead and look at what the execution information is, and based on that, we actually populate the information for results for the contributor. So I just wanted to dive into brief pieces of code here so that we understand the different pieces that are required to actually execute this demonstration. So we are using the ArcGIS JavaScript API, and Data Reviewer JavaScript API is part of that API. So here we are including a bunch of tasks from Data Reviewer, which is batch validation task and a bunch of parameters to actually input what you're trying to validate. We also identify what sessions we need to actually pull information from or write results to. So we use those requires here. And also we use the reviewer results task, which will help me look up the results and display it back to the user. Here is the contributor. So the next thing we do is, as a logged in user, as a contributor, I actually get in the session information and actually identify a session to be used for the contributor upload. The next thing is to actually upload the data which we just uploaded to the server, and we get the uploaded data as a file database. Once we do that, the next step is to define our batch validation parameters, and I define the title that I set up in the application right now, and then I also point to a predefined batch job, which is uploaded as a file item into the ArcGIS server. So then I also point to which session the user is going to actually, the contributor is going to actually write the results into after the validation is done, and point to his uploaded data. Once I set up all these parameters, the next thing I do is basically go ahead and execute a job. When I execute the job, I get back a job ID, which tells me the information about this job as triggered or been scheduled and offloaded to the batch validation service. So once that is done, I go back and look at the progress of this job primarily to actually say if the job status is completed. If the job status gets completed, I go back and get the results from the reviewer workspace and display it using reviewer results task. So this is the key pieces involved in the demonstration we just saw as part of automated validation review. Cool. Next.
So any questions on that bit? So what we did there, oh, go ahead.
It's actually a custom built application just for the demonstration. So I can definitely put it up in a GitHub so we can have it available for you guys. Yeah, it's not like a fully blown app that we built. I just built it for the demonstration. Mm-hmm. Yeah, sure. I mean, it's there. I can put it into GitHub and I can send a link to you guys. Yeah.
Cool. Any other questions? Cool. Okay. All right. So in the first section, we talked about taking business requirements, implementing those as a series of checks, reviewer checks, and then storing them in a reviewer batch job and using that batch job to execute a validation using geoprocessing services and a REST endpoint in server. So that's all great and fine. Automated review, we talked about being really fast and helpful when validating data automatically. But unfortunately, it really only works against data that exists. So there are still scenarios where the data's not there, or it's miscoded in a way that doesn't trip up one of our automated checks. So semi-automated review really is more about how do we involve people in assessing quality of data. And typically these are guided workflows because it's oftentimes repetitive in nature. So we want to streamline that process of getting eyeballs on data. It is subjective because there are people involved. And so typically folks who do review of data are as subject matter experts. And they need to know the data well enough to be able to make consistent calls about whether data is good or bad. Oftentimes organizations use some sort of sampling when doing semi-automated review because it's not oftentimes cost prohibitive to do 100% review of all features. That said, we do have customers do 100% review of every single feature. Usually that's in certain organizations that have pretty important goals. Let's say national security goals, things like that. So there is value in these workflows, and visual review is the most commonly used form of semi-automated review. And that's essentially being able to, looking at features, identifying features that are positionally out of place, that are missing. It allows you also to find sort of patterns where you might see systematic errors in data that may not be found using an automated check. It's oftentimes used when you have a trusted source. So some organizations have the editors using one form of data, and maybe there's a different trusted source of data elsewhere they don't have access to for various reasons, and that's used to kind of find errors that way. So the benefits of this is you get people who know the data really well involved. You get their feedback. You also can use this as finding errors that you can't find normally. Finally, because you're using Reviewer to automate this process, you create results as you would using an automated check. So all the errors, whether they're detected using automated methods or tools Reviewer provides either in desktop or in server, they all get tracked and reported and managed in a consistent way. All right, so in this demonstration, what the organization's done is they've outsourced its data production, but they still want to be able to go and do some sampled visits or do some random sampling on features and send field crews out to verify the position of these features. Because remember, quality is super important because this is kind of a critical asset for emergency responders. So the on-site crews will take a randomly selected set of features and they'll visit them. Some of them they'll pass as being good, others they'll fail, either because they're positionally out of place or they're miscoded. And they also, while they're out, they'll look for missing features. So oftentimes when folks are digitizing features from photography, you might have issues with canopy, you might have other things that obscure what's going on. So sometimes you do need to go on site to collect features. Of course, all that information is being logged and stored as a reviewer result, where it's shared through a portal. And then editors within the organization can use that information to go and make the proper fixes in the source data. Okay, let's go ahead and take off.
So for the second demonstration, as Jay set it up, we are trying to actually log in as a field crew. So we have a field crew who actually goes around based on the contributor collected data, get a sample of those collected points, and then go in and actually look at those points in the field and visualize, are they actually positionally accurate? If they are positionally accurate, go back and say this is a good collection or a bad collection. So we do this by using ArcGIS Data Reviewer's capability, the automated validation capability initially to get a sample. Once we get the sample, we go in the field to actually evaluate the results. So let me log in as a field tech. So here I'm logging in as a field tech. I have an imagery data to just show you guys, but at the demonstration is set up in a way that, I mean, as a field crew, I can build this application as a JavaScript application and take it into the field using a tablet or a mobile device. So here I have the data of the address points collected by the contributor. These are the driveway entrance points that have been collected here. So here I can go ahead and quickly trigger, as a field tech crew, I can go and say, get me a sample size. So what I'm doing here is primarily using the automated validation capability to trigger a sample check batch job, which goes by a certain confidence level of 98% and certain percentage of error allowed for that sampling check. Based on that, it created a sample for me. So now I can go ahead and say, I'm looking at this sample. So I can look at each of these issues and say, okay, is this a good sample collected correctly? So it talks about a driveway entrance, if you see, and it does seem to be the right driveway entrance information correctly. So I'm going to select that, and I'm going to say, I'm going to go ahead and mark it as a pass status. So you see that the status of the life cycle status of that information has changed to pass, and it goes from a review phase to a verification phase, which is it's been verified. So as I skim through it, I can actually go and do a couple of other ones and say, okay, this seems to have a problem. There was a tree there from the imagery data, but the driveway entrance is probably not right there. It's a little further away. So I can go ahead and select that and click failed. So this needs to be reevaluated, and it will go back to the contributor for reevaluation. So I'm marking them as a failed results. So as I go through them, I can also navigate through them as I drive through. I see that there are driveway entrance points collected and see if all the driveway entrance points are collected accurately. So here I have a driveway entrance point defined at a certain location, but the driveway entrance is on the other side right here. So what I can do is I can go ahead quickly and identify it as a missing feature. So I have the reviewer's capability to write or mock features up in the map. So what I can do is I can quickly select this and say the driveway entrance should be here, and I can select the entrance point, say it's a positional error. So I can define a severity to the problem, and I can say, okay, and report it back to the organization. So as I report it back to the organization, it goes back into a review phase. So this can be either translated back to the contributor to say, okay, this is incorrectly collected, so you need to go back and fix this, or they can evaluate that issue and then report it as a problem from the organization's perspective. So what we did was quickly try to sample the data and go through the sample and look at them and see if it's good or bad, as well as identify if there are any missing issues or repositioning issues on the data. So let me switch to the slides to show a good summary of what we did today. So we used the data reviewer's sampling check capability to create a sample size. And once we had the sample, we used the data that was collected by the contributor, and we got a sample out of it by running a validation service. So when we run a validation service, it triggers and gets me a bunch of sample results. So when it has a sample results, I take the sample results on the field, go and look at each of them and mark them as pass or failed. I do that by using something called update lifecycle, which is updating the lifecycle of the sample record that I just found, marking it either as a passed or a failed record. I also went around trying to find, okay, there is a missing feature, so I reported it as a problem by using the write results endpoint back to the server using the server APIs and into the reviewer workspace. The reviewer workspace had all this information now, and an editor, a desktop editor, could potentially look at the problem and see if that is a valid issue. Should we fix it as part of the organization, or should we pass it on to the contributor to fix the problem on his hand? So this is an overall workflow of a semi-automated review and how reviewer provides some of the tools to actually do the semi-automated review. To just highlight some of the code bits here, we have the same JavaScript requires which we need, which is the results task and the lifecycle class, which will allow us to update the lifecycle. Then we created a sample. To get a sample, we created batch validation parameters and executed a job, which will give me a sample size. Once we got the sample, we selected a sample and said passed or failed by calling a method called update lifecycle in review results task. Once we did that, we reported the problem as a passed or failed. We also went around marking issues. The way we marked it out is we required the reviewer results task as well as some reviewer attributes so that we can identify what the problem is when we report that back to the organization. So we identified it as a missing feature. So we created some attributes saying we defined a severity to the problem. We said what type of problem it is. And then we actually went ahead and used those attributes to report it as a problem using the review results write result. So once we did that, it was again available for the organization to evaluate it from a desktop editor's perspective. He can look at the problem and say, is this a real problem? Should we actually pass it on to a contributor? So that's kind of what we did as part of the second demonstration.
Right, so any questions on that section? So essentially what we did is, the first section we talked about automated review. The second section we talked about how do we do some manual or visual review of this and use a sampling check, which is one of the 43 checks, to generate a random sample, visit features, pass, fail them. We'll talk about the lifecycle status of results in a moment. And then use that from a common repository so that editors and everyone knows what's going on with the quality of the data. Switch over. All right. So in this section, we're going to talk about what do you do with these results? How do you use them to summarize information quality? How do you use that to engage a different stakeholder audience? So the results that we've been collecting really are built to help answer a lot of different questions your organization might have. So there might be questions they ask about where spatially are these features in my database? And can I use that information to do some sort of a hotspot reporting? Am I seeing poor quality data in certain areas of interest that are different? And why is that happening? How severe are the issues? Not all errors are as important as other ones. So you saw in the demo, Shankar was setting a relative error severity. There may be some features that when they're in error, they must be fixed within, say, 30 days. Other errors, maybe lower priority, they just are there to be monitored. So we want to be able to say, well, how many important issues do we have in our database and how many other ones types as well? What types of issues are there? So when we think about simple attribution problems with data, that could be real easy fix using a bulk calculate on a field. But if we have problems with our data because there's improper spatial relationships between features, that might actually take more time. It actually might take a different type of editor to do that work. So you can use this information to kind of understand and do some workload estimating based on, I've got these numbers of errors, it's going to take this long to fix, and need a skill of this type. So you can kind of do a little bit of thinking about how long it might take to actually fix these things, especially if you're working in an organization that has a budget involved and you need to be within budget or under budget to get the work done. And then also, am I seeing patterns in the sources of poor quality? So being able to look at the results and look at it by the source. Why am I seeing more errors in my road centerline data or my routes and less errors in my sewer pipeline? Information about where it came from. Maybe you could use that information to either provide some extra training to staff who may be underperforming and creating poor data, or you have contributors who are providing data to you that tend to always have problems with quality. Maybe they don't get the job next time. And finally, what is my organization's progress on resolving these issues? We've got all these problems. Where are we at? Are we moving forward, or are we moving backwards? Are we actually getting worse on quality rather than getting better on quality? So these are kind of some of the questions you can answer using the results that we've been gathering with Reviewer. So reviewer results really are an object that has both a spatial component, and we oftentimes refer to that as the error geometry. So you may have a business rule, for example, that says lakes shouldn't overlap land like bare earth. Well, you might have a lake that's super huge, but the error geometry may just be certain spots on that feature. So it helps to have an error geometry because it helps corrective workflows and fixing it rather than having to figure out where's it overlapping. We'll take you right to that. There are also non-spatial information stored about the source, what were the business rules that were, the check configurations, the severity, who found the error, and when it was found. Finally, there's an identifier that allows you to take that result and associate it back to the original feature that was found to be an error. Because there are scenarios, oftentimes, where you might have actually more errors than features in your database. Because a feature may fail multiple times on different business rules. Finally, results have a defined life cycle. So when errors are found initially, they're in a reviewed state. When we correct them and use reviewer tools to update their status, it moves them from a review to a corrected. And for some organizations, they actually have folks who verify results and make sure that the fix was appropriate and correct. And if not, it's sent back. So we have a very defined workflow. It's not just simply a domain. It actually, under the hood, we manage that life cycle. I don't think we may see that in demo, yep, where results will go back and forth to different phases. So these results are stored in a geodatabase. We oftentimes get asked, do you need to put it in its own special geodatabase? No, just any geodatabase, any flavor you want to use. And we can use those results to either report out that information in a tabular form. I think you might have already seen that little table widget that had just the row by row information about the errors. But also these results can be reported and aggregated as summarized values that are really great for using in infographics like pie charts, bar charts, and things like that. And there are capabilities for applying filters, both spatial filters as well as attribute filters, to define a subset of features you're interested or results you're interested in. All right, so in this demonstration, we're going to leverage all the information we've been collecting throughout this process to help do some reporting to a couple different audiences. So using the reviewer results that are stored in our database, we've got results from our automated review. We have results that were collected during our semi-automated review. At any phase of that workflow, we can be reporting out the progress and where things are today or tomorrow. We'll be leveraging that information to enable both internal to the organization stakeholders who maybe need to know overall how good or bad the data contributors are in terms of their performance, as well as the individual contributors being able to know how good or bad their data is so they can go back and make it better. Okay, let me turn it over to Shankar.
So we're coming back to the same contributor portal. As a contributor, actually, I uploaded some information and I said, okay, I've collected these points, evaluate my data, and I submitted it. It triggered a validation, we got some results. So as a contributor, I want to go back and look at issues that have been found as part of my upload, and also understand where they are co-located or what type of issues they have. So what I'm going to do is I'm going to log in as the same contributor who just uploaded the data. So as I come in and log into the portal to look at the issues, so these are my collected driveway entrance points that I've done, and you can see that there is information about those driveway entrance points already. So as a contributor, I come in and look at the results, but I also have the data that I uploaded here for me to visualize where the issues are. So I'm going to use the dashboarding and results capability of Data Reviewer for server. So what I'm doing is basically, as a contributor, I come in and I see that there have been so much issues reported. There are like severity 5 issues that have been reported for 89 of them. There is 14 issues reported as severity 1. So if I click on them, I can actually then use reviewer's results capability to actually look at the actual results filtered by that severity 1. So essentially, I'm filtering my results or summaries based on the fact that I have a severity of 1 results. So I can quickly go into each of them and see what the problem is. It says incorrect site address key. So I can highlight that. I can see what is the problem here. So the site address key that I have in here, let me switch to the actual site address entrance points that I collected. So the site address key that I have here is incorrect because it's null. So I have not put in correct information here. So I can quickly say, okay, this is the problem. So which means there is a collection issue here. When I collected the data, I forgot to put or update attributions for some of these site address keys. So there is also other issues that I could look at, which would be different types of issues that I can see. Also I can do is, I can go back, as Jay spoke about some different perspectives that you can look at the data. I can quickly go in here and say, I want to find things based on different types of issues reported, or different feature classes on which the issues happen. So I can go in and say different types of issues. So I have different types of issues here. So I have the missing site address ID information here. Then I have some missing address entrance points on parcel. So if I click on them, so I can go to the parcel and says, okay, this parcel is missing some address entrance point. So I can quickly go navigate to them, look at the actual results, and identify the actual error geometry where the problem is. So I can go back into this area, and let's say I'm looking at a specific sector of this map. So what I can do is, I can say I want spatially, I can filter these results by a certain area in the map. So I can say draw a result selection on the map and click on a certain selection of the map. So then I can go back to the dashboard and it will give me a much simpler subset of those errors, which is some missing address entrance points on those parcels. And if I click on them, I will be navigating only to those issues. So I can quickly geographically constrain the area that I'm looking at and actually look at the specific issues. So as I said, there is also different perspectives to it. So I can now log out as a contributor. I'm logging out, but as an organization's program manager who's trying to actually look at how people have contributed data to this, I can quickly have that different perspective by logging in as the administrator here. So as a program manager, I come in and say, okay, people have collected data, so I have different contributors collecting data. So let me look at what's the status of those results. So I can quickly go into this and see what are the different severity of issues that have been found. I can also quickly go by the different contributors here, which I've classified as sessions. So here I'm classifying a session. So I see that there is a field crew who have collected some information. There's a field tech crew that collected information, which we saw in the earlier demonstration. And we also see the the contributor uploaded data, which is team A, which has collected that information. So I can click here and see where they are at. They're all in review phase. So they are still yet to fix those issues. If I go and look at another team, like a team B, then I can look at different scenarios. So different issues here, and some of them have been marked acceptable by those contributors. So when the next upload happens, we can evaluate this issue, that they have fixed these issues, and compare it to the automated validation results. So the last piece I wanted to show is, as a contributor, how do I actually mark an issue as fixed, and how the administrator or the organization stewards can actually go back and verify them as a valid result. So I'm going to log in back as a team, as a contributor here. I'm going to look back at my issues. So I'm going to take the severity 1 issues, and I'm going to click on each of those issues and say, okay, this issue has been fixed. So in the next upload, I will be able to fix this. I'll be able to mark them as fixed. So I'm going to resolve this. I'm going to go ahead and update this. So now I've marked this issue as fixed, and I can select a bunch of other issues of all the incorrect site address keys and identify them as fixed. So what I've done is, as a contributor over the web, I can update the status of those issues that have been reported by the organization. So as I did this, the organization on its part can look at the next delivery and come back in and update it and say, okay, these issues have been verified, these issues are not fixed. So they can go through a lifecycle process wherein they can log in back and look at contributor A's results and go to their severity 1 issues and says, okay, the contributor has marked these things as resolved. So let me go ahead and look at these issues. So let me pick a few issues here. As I look at them, I see if I see that the issue has not been fixed, so I can what I can do is basically select those issues and say, okay, this has not been fixed. So I can go back and say it's unacceptable, it's not been fixed. So what it has done is basically I've had a mechanism to actually define that a mechanism in a life cycle phase process wherein I go through an error correction from starting from review phase to correction phase and back to a verification phase or back to a review phase if the issue has not been fixed correctly. So the next thing I wanted to actually quickly navigate through is, as part of the demonstration, what we did as part of reporting and looking at the summaries as a filtering mechanism. So here I needed the dashboard task, which allows me to dashboard the information of results, and I also use some results parameters to identify or filter those results. So I use the dashboard task here. So basically I set up the filters as the different contributors as sessions, and then if there is a spatial filter identified, like I drew a map area where I can filter the results for that specific geographical area, I can pass that information and I can call the get dashboard results. So when I call the get dashboard results, it will return me a summary of the results in a certain format, and I can use that to display it in the chart as a pie chart or a bar chart using the Dojo JavaScript API calls. So also what I did was, when I clicked on those chart areas, I could actually look at the actual results based on the same filters that I've applied on the dashboard. So the way I did that was actually I used this what is called a query parameters in the results task to define how many pages of results I want, what is the size of the for each page, and which page number I want, and also the same filters that I've applied from the dashboard. So I use the results task get results and pass these parameters and get some results and populate them as a grid. So just to summarize the overall architecture of different capabilities of automated, semi-automated, and visual and as well as reporting and analyzing tools, what we have as part of Data Reviewer is we have the REST APIs calling into a batch validation service, which offloads it to a geoprocessing validation service, which will use the data that has been provided to validate the data and return the results into Reviewer workspace. So once the results are returned to the Reviewer workspace, there is also the semi-automated mechanism where I have a visual review to evaluate those issues or report markup issues and report it back to the results workspace. Once those issues have been reported to the Reviewer results workspace, we can then take them and use and dashboard them using Dojo charts and or tabular formats as results. So wherein you can apply some interactive filters to evaluate them. So,
all right. Any questions? Pretty straightforward stuff, right? All right. So, I'm going to switch over. Cool. All right. So we covered a lot of ground there, right? So just some resources to go back if you want to learn more about it. Documentation, ArcMap, as well as pro documentations available from the desktop ArcGIS site. Server, we have a landing page on the server.arcgis.com location where you'll find links to the JavaScript APIs, links to our web app builder widgets. There's also a series of tutorials on how to deploy and configure these services from start to finish and deploy either automated validation capabilities or widgets to deploy some feedback mechanisms in your maps, as well as dashboard widgets, how to deploy those services as well. We also have a good amount of starter apps that you can get started with. There's a link to our gallery on ArcGIS Online that you can download starter apps to get started with. We didn't really talk about them, but you'll find links to those as well on that page. Lots of different resources for training. So we've got a couple free training seminars available that you can just sort of take, little short 1-hour sessions. And we also have a growing number of web courses, which are self-paced courses for taking, learning more about automated validation, visual review. I think for folks who are on maintenance, those might be free at this point. There's also an instructor-led online class, or instructor-led class, which kind of goes real deep dive on how to implement Data Reviewer, configure checks, validate features, and work those through the life cycle. That's either online or at your site. Finally, we have a place on GeoNet. So if you want to ask questions, the team monitors the Data Reviewer place on GeoNet. A lot of customers will pose questions there, and other folks can chime in on it, or we monitor it and provide feedback as well. So it's a great place to kind of go and to learn more about what's happening. All right, so thank you very much for attending. We really do appreciate you attending on a Friday morning. If you have a moment, if you take an opportunity to provide us some feedback on how the session was so we can make it better next year, just find our session in the events app. Scroll on down, go ahead and provide your feedback and hit send. Let us know how we did today. We've got a few minutes. If folks have questions, we'll be happy to stick around and answer them for you. But on behalf of Esri, thank you very much for attending this morning.